Modeling categorization not exclusively encodingly, be that as suggested by Aristotle, Roche or Zadek, but also with the help of selection out of a communicative field, out of what the brain can likely be potentially thinking about at every step of interpretation process, avoids several problems. First, it avoids the problem of having to find an appropriate set of features defining all members of a given category, or finding the right prototype shared by all the speakers of a given language community. This is so because if we agree that words may also serve to select the best matching item out of the set of options, we realize that different category definitions, just as different prototypes, may serve to point out the same outcome in the same set of options. So we do not need category definitions to be perfect and identical for everyone. Selection also explains why we can use successful elections and sentences to convey the content they do not encode. This, as you remember, is a problem also for a fuzzy sets model of a category. We can use the word squirrel to mean a bear selectively on occasions when the options the brain is thinking about do not include a better example of a squirrel than a bear is. For example, if we say, "Look what a cute little squirrel this is," when standing in front of a cage with bears in the zoo, we mean to characterize some bear, not some squirrel. This illustrates how we use language metaphorically and also explains why language can change over time. If new situations arrive, for instance, new technology or new social relations, most of the time old words are capable of selecting them. And if used consistently with a given meaning, these words start encoding that novel meaning, either exclusively or in addition to the old one. No less importantly, selective mode of language use accounts for the compositionality of meaning, which on closer look is much more tricky than it might seem. Note finally that selective mode of language use has not been introduced in place of the encoding mode of language use, but it is postulated that the two modes of language use coexist. If accompanied by a selective mode of language use, the encoding mode of language use no longer needs to account for every instance of language use, but just for most typical cases, which ensures the stability of language over time. Selection accounts for the ability of language to change and to adjust to specific occasions. Both selected and encoded uses of language contribute to current encoded values of words in use. Note that when accounting for semantic compositionality, categorization of the meaning of linguistic constructs, phrases, and sentences with a selective use of language use, we do not aim at finding the algorithm that would let us calculate the meaning of a sentence out of the encoded meanings of its components, which was once the holy grail of linguistics. This time we search for a rigorous procedure of selecting the best matching item from the given set of options the brain is currently focusing on. The same holds for categorization. We need not look for a perfect category description, but for the procedure that will let us select the right interpretation using an imperfect encoded category model. Such a procedure can be modeled in a strict way. So, to arrive at a better model of categorization and compositionality in natural language, we need to do two things. On one hand, we need to find the formalism which would reflect the selection procedure. In computer sciences, there are many formalisms doing just that under the name of supervised learning. So, to try out this step does not seem to be extremely difficult. If you want to learn about such formalisms with a history of linguistic applications, you may want to start with Simena software by Andrei and Helen Włodarczyk of Sorbonne, or analogical modeling introduced by Royal Skousen of BYU. The second challenge concerns modeling the communicative field. In other words, what the brain is thinking about at the given moment. This type of research has been done under the umbrella of association studies. Association research has a very long tradition. A recent out-of-the-box proposal I want to mention here came from Peter Bruza and his associates. Peter Bruza researched the recall of words in response to a clue. He found out, for instance, that in response to the clue space, if Earth comes to one's mind, so does the Lexian planet, but not, for instance, a gas giant. Interestingly, what let Peter Bruza summarize the data collected well was quantum mechanical formalism, used for the description of entangled, not separable, in some sense elementary particles. From that, the researcher draws a fascinating conclusion. As a phenomenon, it suggests that the world is not the separable and reducible place that we have always taken it to be. If entanglement is found in other types of non-physical systems, it will suggest that the quantum formalism is modeling non-separability per se, and this will indicate that quantum theory could provide a whole new approach to the study of complex systems, which are not separable and irreducible.